Hi everyone. In this video, we are going to discuss a very important theorem in the field of distributed system known as CAP theorem. This theorem was initially coined by Eric Brewer in 2000, and hence this theorem is also known as Brewer's theorem. CAP is an acronym of consistency, availability, and partition tolerance, which are attributes of a distributed system. We will discuss all these attributes in detail, which then will help us to understand CAP in a better way. Finally, we'll also discuss why understanding CAP is important for data engineers. So without further ado, let's dive into it. Before we discuss CAP theorem in detail, it's good to have a fundamental understanding of distributed systems. A distributed system is a network or collection of independent machines, also known as nodes. The end user, it appears to a single coherent system, and these nodes or machines work together for exchanging the data, for distributing the task, and to achieve the common goals, which is scalability, fault tolerance, and performance. But building distributed system or designing distributed system is not easy, and it comes up with a lot of challenges. These challenges are data consistency, availability, and network failures. And this is exactly what is also highlighted by CAP theorem. I think with this understanding, we can appreciate CAP theorem more. So let's discuss the individual component of CAP theorem. Starting with consistency, every read receives the most recent write or an error. So errors are acceptable, but the consistent output is the desired behavior. Imagine if you have a system with two nodes, N1 and N2, and having value of x equal to 10 in both the places, the user would get the same value. Now, if you change the value from 10 to 20, it must change simultaneously to the other system, or it shouldn't say that the operation is successful until the value is same in both the nodes. Otherwise, the user will see the inconsistent output of X. And this behavior is very important in systems like financial transactions or e-commerce website. Availability, on the other hand, is every request receives a response. They may relax consistency, but they cannot relax the error. And such systems are very important in systems like healthcare or retail. Partition tolerance is about system must work even if there are network failures. What does it mean is, imagine this as a distributed system, and somehow there is a failure or outage, and it breaks the entire network into two pieces, which is known as partition. So having this partition, the entire system must work. It means the system is partition tolerant. Such behavior is desirable for applications like cloud computing or social media platform. I think with this understanding, now it's time to deep dive into the CAP theorem. So now you have a good understanding of individual component of CAP theorem. It would be much easier to understand this theorem. So what this theorem says, a distributed system can deliver only two of the three desired characteristics. So out of these three characteristics, which is consistency, availability, and partition tolerance, you cannot have all the three in one system. You cannot. You have to sacrifice one based on what are your requirements, what system you are going to build. You can just pick two properties, two characteristics out of these three. Some examples of systems which are CP having consistency and partition tolerance are HBase and Redis. For systems which are highly available and has partition tolerance are Cassandra and MongoDB and Cosmos DB. And systems which are consistent and available, we have Postgres and MySQL. These systems basically would be fall into category of single node clusters. Just now we saw in cap theorem we need to pick 2 properties out of 3. But in reality we need to pick 1 property out of 2. We saw that partition tolerance is an important property which makes your system more resilient towards failures. These failures could be network failure or hardware failure. But these failures are unavoidable. They are bound to happen. And if so, it means partition tolerance is a must-have property. If partition tolerance is constant property in your system, then your system can either be consistent or either can be available. We cannot have both. Now, this makes the entire cap theorem even more simpler. So instead of picking 2 out of 3, now you have to pick 1 out of 2. Isn't it simpler? Cool. Now we saw how easy is cap theorem to understand and how important it is for any data engineers. My top 3 reasons why a data engineer must learn cap theorem is it helps them to design their system better. Now with a better understanding of cap theorem, they can have trade-offs between design choices. This theoretical foundation helps them to converse well with their peers, and it helps them to engage more in the reading of technical literature around big data systems. And you may impress interviewers if they ask you questions about cap theorem. I think this video will help you and you found it engaging. Thanks for watching.